and adab dear students. Today we will discuss riveted connections in steel structures. So first we see what is a connection. A connection is basically a joint between two members in a steel structure component. Say for example we have a member which needs to be joined to attain the required length. We use a joint, we install a joint over here. By certain means we connect them together, and this part is known as the joint. Now since it is a joint where two members are being connected by certain means which may include drilling of holes, etc., this joint becomes a weaker section. So we have to take care of the strength of this member at that particular joint. There are various possibilities. If we come to the type of connections, there are various possibilities how we connect the members together. One may be a riveted connection, it may be a welded connection, it may be a bolted connection, or it may be a pinned connection. In this video, we will elaborate on riveted connections only. So a riveted connection, its analysis and how we ultimately get the strength out of a riveted connection. So first of all, let's see what is a riveted connection. Say I have got two members. These are two plates which are needed to be connected to each other. This is another plate. If we show in the cross section, this is one of the plates. This is the lower plate. Okay, these two plates are just lapped with each other, overlapped, and we have to connect them by using certain means. So what I do, I drill a hole over here. Say for example here. In the cross section, it will appear like this. This is the hole drilled. Now we make use of a rivet, as the name specifies. It is a riveted connection. So we are going to use certain rivets, certain members, certain structures which are called rivets. How a rivet looks like? It looks like a bolt but without a thread. This is the rivet head. It has got a circular cross section. This is called the shank. It has got a certain diameter phi. It has got a certain length. So what we do, we use this rivet and fit it inside this drilled hole. When it fits inside the hole, it looks like something of this form. The head fits over here. Some part of it projects beyond the edges. Now we have to make some permanent fixture out of this rivet. What we do, we keep it mechanically pressed over here, apply mechanical pressure from this particular end. This part of the shank gets distorted and gets converted into a head-like structure as it was at the top. Now the members are fully connected to each other. Now they won't move, and this is the basic principle how we connect the members using this rivet. Now number of rivets, etc., that will vary with respect to the load, with respect to the members which we are connecting. It will depend upon various number of factors. Now this rivet, this can be more. Say if the need arises, I may put rivet something like this, or this line. This is called a rivet line now. Now a rivet line will have number of rivets fitted along in it. If the need arises, I may have to use another rivet line. Fit some rivets over here also. So this will be another rivet line. It will appear in the cross section like this. So this rivet will be shown over here. So depending upon the load, depending upon the capacity of a rivet to take the load, we have to provide certain number of rivets and their arrangement as well. Now the distance comes into picture. We have to have certain distance which will follow our norms and will prevent the failure of the plate also. So this distance where we are center to center distance, where we are providing these adjacent rivets, this is called the pitch. We have to provide certain minimum pitch so that tearing does not take place. We have to keep some gap in between the two adjacent rivet lines, which is called the gauge. Okay, we have to maintain some distance from the edges as well. From the edges we have to maintain certain distance at both ends. So these distances are called edge distance. So we have to make the arrangement of the rivets in such a way that number of rivets is provided. We follow all the norms. The plate is not tiered. The tearing strength of the plate is also satisfied. So that provision we have to take care of when we provide the pattern of the rivets. So after this we come to the types. We have types of riveted joint. We have two basic types of rivet joint. One is the lap joint. Another is a butt joint. So we can provide these riveted connections either by lapping the members or providing some other means in a butt joint. First we will see what is a lap joint. Lap joint is just like this, where the members are lapped over each other and then the rivets are provided depending upon the design, depending upon the strength of each of the rivet and the load to be sheared. That pattern is decided and certain rivets are provided in this form, but the members are kept lapped. This is the lap length. So we have to maintain this lap length, a minimum one which is required for economy purposes. Now depending upon how many rivet lines are there, we designate this further as if there is only one rivet line, we call it a single riveted lap joint. We call it a single riveted lap joint. If we have provided more than one rivet lines, it will be a double riveted lap joint, and so on. Depends upon the number of the rivet lines provided. Number of the rivets along each line can be different. It can be number of rivets, many number of rivets can be provided as per our requirement, but this single and double will only be categorized with respect to the rivet lines. So this is a lap joint in which we lap the members together. Then we have a second type of joint possible, which is called a butt joint. Butt joint, in this no lapping takes place. If we have to connect two members together, we bring them face to face. This is one of the plates. Another plate, just leaving some expansion gap in between, we put it like this. If I show the cross section, this is one of the plates, some gap in between, and another plate. These are the two plates. Now here we have to make use of rivets to connect the members together, but in order to connect these members, we have to provide some common member which we call a cover plate. So these members are connected to a common member which is called a cover plate. So this is called a cover plate. Cover plate, as per our requirement, we can provide a single cover plate or we may provide two cover plates, one at top and one at bottom. Then, depending upon our design, how many rivets are required to be provided, we decide the pattern of rivets. Say, I am providing rivets along this line on both the sides, in both the plates. So this will be a single rivet line. This will be categorized as a single rivet line, not double, because there is only one rivet line in one plate. So this will be categorized as a single rivet line. And how many cover plates we are providing? If I am providing a single cover plate, so this will be known as single riveted, single cover butt joint. If there is only one cover plate, there is only a single rivet line in each of the plates, it will be categorized as single riveted, single cover butt joint. If there are two rivet lines, so it will appear like this. There are more rivets now. In the cross section, there will be two rivet lines visible. Okay, this is one, this is another rivet line. So there are two rivet lines visible now. Now, if there is only one cover plate, then it will be single riveted, will be double riveted, single cover, butt joint if it is only one cover plate and two rivet lines. Then accordingly, if I am providing both the cover plates, it will be a single riveted double cover butt joint, or it will be a double riveted double cover butt joint. So you have to see how many rivet lines and how many cover plates we are providing. This is the butt joint. Now we provide these rivets to be more specific in a certain pattern. That riveting pattern may be of three types. If I provide rivets in the plates to be connected simply like this, as we saw in the previous cases, if we provide something like this, rivets there are equal number of rivets along all the rivet lines. This is the most simplest type of form what we can provide. This we call chain riveting. Okay. If the number of rivets along various rivet lines is varying, if it is not same now, if we vary number of rivets, if the need arises to vary the number of rivets, say I am providing rivets like this. If this is the pattern where the number may not be same along all the rivet lines, this is called staggered riveting. The staggered pattern of riveting, where the number of rivets may be different, while the distance, this distance we call staggered pitch S. This is the pitch along one rivet line. Okay. In case of butt joints, a special pattern of staggered riveting is possible. Butt joint, as we saw, that it is plates provided face to face, making use of certain cover plates, and then providing the rivets. Say this is the cover plate, and we are now going to provide rivets. That is staggered riveting, but in a particular pattern. Say our rivet lines are like this. I am providing 3 rivets here, then it's 2, then it's 1. Same pattern on this side of the joint. Again 3 here, 2, then 1. So this forms a diamond pattern. This is called diamond pattern of riveting. But this is possible in case of butt joints only. So we may provide any of the patterns depending upon the case, depending upon the numbers to be corrected. We may use chain riveting, staggered riveting, or a diamond riveting pattern. Ultimately, we have to see how much load our riveted connection is resisting. So we come to the strength part. Strength of a riveted connection. See, there are a number of modes of failure of a riveted connection in which either a rivet can fail in a connection, either a rivet can fail, or the plate itself can fail. So any one of the two failure will be considered to be the failure of the joint. So depending upon the failure modes, 3 prominent modes of failure have been identified. One is called shear failure. This is the failure of a rivet. So one is the shear failure of a rivet. Then second, bearing failure. This is also, bearing failure is also pertaining to the rivets. So bearing failure, either the rivet can fail in shearing or it can fail in bearing. Then we have tearing failure. Tearing failure of a plate. Now this is not the failure of a rivet, this is the failure of a plate. So these are 3 prominent modes. There are other modes as well, but 3 prominent modes where a riveted connection has maximum possibility of failure. So what we do for calculating the strength of a riveted connection, we calculate all these three values. We calculate the strength of riveted connection corresponding to the rivet failure as well as to that of the tearing failure of the plate, and then we analyze the minimum one we arrive at as the strength of the particular joint. So we will analyze them one by one. Shearing. We call it shearing strength of rivet. Shearing strength of a rivet. Say these are the members which are lapped to each other. They are connected together using a rivet. This is the rivet. If we pull the members like this, there is going to be a shear failure over this cross section. The rivet will fail at one cross section. So this we call as single shear failure. This we refer to as single shear failure. Then if we have more than two members, say we have members like this, and the rivet is here, we pull the members, the rivet is going to fail at two cross sections. It is going to fail at two cross sections. That means it is a double shear failure. So shear failure can be single or it can be double, and the strength which this rivet, which a single rivet will maximum bear in shearing, will depend upon its single or double shear failure, and that will be equal to the area of the rivet, pi by 1/4 d square. This is the area of the rivet, multiplied by tau Vf is the permissible stress in shear. This is for single shear. If it is double shear, you just have to multiply it by 2. So this will be the strength which one rivet will at the most give us in single or double shear. This is the failure of a rivet, not that of a plate. Then we have bearing strength. Bearing strength of a single rivet. Again, we consider the members, two plates which are connected to each other. This is the rivet. The rivet may give away due to bearing stress. The bearing stress may develop along the periphery of this rivet. So that is also considered to be a failure. So the resisting area is only this much. If this is the thickness T1, this is the thickness T2, the minimum of the two we consider that will fail first. So this bearing strength of one rivet, strength of one rivet in bearing, this shall be taken as, this is T, T1 or T2, whatever is the minimum. This is the gross diameter D. So D multiplied by this T is the minimum of 1 and 2, multiplied by sigma PF is the bearing stress, permissible bearing stress. Tau VF was permissible shear stress. These stresses, tau VF, sigma PF, these will depend upon the type of the rivet. What type of rivet we are using, these stresses will be taken accordingly. The type of rivets has been specified in IS 800. The type of rivets can be power driven shop rivet. Stresses are specified 100 Newton per mm square for tau VF and 300 Newton per mm square for sigma PF. It may be a power driven field rivet where the stresses are relatively less, or it may be a hand driven rivet. So depending upon the type of rivets, we take the values of tau VF and sigma PF from IS code, then we calculate its shearing and bearing strength. These are the two modes of failure for a rivet. Then we come to tearing failure. This type of failure pertains to the plate. This is called tearing failure of plate. So plate may get teared. How? Say this is the riveting pattern. These are the rivets provided. Okay. Now plate has got a certain width, we are reducing the area by drilling holes. Tearing may follow a certain pattern, say this is the pattern. If tearing takes place here, we have to find out the net area along this particular failure plane. Okay, so that means we have to find out net area. Net area will be B is the width of the plate, minus N into D multiplied by T. This will be the net area. Then strength will be B minus N into D multiplied by T multiplied by the permissible axial tensile stress in the plate. So this net area we will have to take at different, we take along different cross sections. The failure may be this way also. Depending upon the failure plane, we have to take the net area. If we are following this plane, there will be more directions, 3, 4 and 5 directions. N will be 5 for this particular pattern, but at the same time we are following a zigzag path. So here we'll have to make certain adjustment. We will have to add this particular length what we are exceeding, then B. So we'll have to add N dash into S square by 4G, where S is the staggered pattern, then multiplied by T, then multiplied by sigma AT. This is the staggered pitch S. Okay, we'll have to find out the minimum one and then find out the tearing. Now we have three strengths. We have strength of the rivet in shear, strength of the rivet in bearing. We have tearing strength as well. So ultimately the minimum of the three shall be the strength of the riveted connection. We'll again sum up this strength of the riveted connection. See, we have a joint. Details of the joint we know. Details of the connection we know. We have to find out the maximum load this joint can resist. So we have two paths. Either the rivets will fail or the plate will fail. This joint can fail either due to the failure of rivets or it can fail due to the failure of plate. Okay. Rivets can further fail either due to shearing. They can fail either due to shearing or they can fail due to bearing stress. There are two paths for rivet failure. If it is shear, we may take it pi upon 4d square into tau Vf, single shear, double shear, we multiply by 2. In bearing, we have d into t into sigma Pf. This will give us the strength in shearing and bearing. Minimum of the two, that we call rivet value. This is the minimum value. Rivet value is ultimately the strength of one rivet that we can consider for design after considering its shearing and bearing failure. Corresponding to the rivet value, we may find out the strength of joint. So strength of joint corresponding to the rivet value will be n times rivet value. The number of rivets which we are providing in the joint multiplied by the strength of one rivet. Finally, what we have concluded here. Okay, this is the strength of the joint, but this is with respect. This is with respect to rivet strength or rivet value. Then we have another wing here, plate. Here, the strength of the joint is the tearing strength. We have tearing strength of joint or plate. So the strength of the joint will be the directly tearing strength of joint, that is net area multiplied by sigma 80. So we have this value directly as the strength of joint. There is no minimum here. It is directly the tearing strength of the joint. Now we have two values, strength of joint corresponding to the tearing of plate, strength of the joint corresponding to the rivet value. Minimum of these two values will ultimately be the strength of riveted joint. Okay, this path we follow to calculate the strength of a riveted joint. Thank you.